So this is a stage that we're at so far. I gave you this as an example, and I gave you this as an exercise, and I gave you this as an exercise. So whenever you want to differentiate this, then immediately jump to this. And whenever people talk about the inverse tan of x, then immediately visualize this in your mind here. And then if they ever talk about inverse sine of x, then immediately visualize this in your mind here. And remember here, the domain here is -1 and 1 here. So this thing here, this thing here is only true. It's only valid for x being in this region here, in between -1 and 1 here. So this thing here, when you differentiate this, it will give you this. But then this thing will only make sense when x is within this region here, -1 and 1. Okay, so bear that in mind. And whenever anyone talk about the inverse cos of x, then try and visualize this graph in your mind here. Okay, and again, this one's valid within the domain here will be -1 and 1. Okay, so try and visualize these graphs in your mind. Okay, so now, well, given these three here, you can now differentiate this. Let's say you've been given this here. Differentiate this here. Okay, so here, so from up here, if you look up here, whenever you want to differentiate the inverse of tan, then you immediately jump to this. So looking at this here, that's exactly the same as this down here. Okay, that's the same as this. So now using this, if you want to differentiate this here, then imagine it as like this. This bubble here is 3x squared here. So if you use a chain rule here, differentiate this. So you can imagine this as being, 3x squared here. You can imagine this as being, try to differentiate this w here. So when you differentiate this here, you would have to differentiate this, which will be using this here, which will be 1 over 1 plus w squared, and then you've got to times w dw by dx here, because the w here is really the bubble here. So my point here is that if you want to differentiate this here, differentiate this as normal, which will give you this here, and then you've got to times the derivative of the bubble itself. So you've got to times, in a way, the bubble by dx. So you've got to differentiate the bubble itself. So for example, if you want to differentiate this here, okay, then differentiate it as normal. So so 3x squared here. Now differentiate this as normal, which will then give you this 3x squared here, and then you don't forget you've got to square it again, because if you look at it up here, whatever the bubble is here, you're going to square the bubble here. So here, you got to square this bubble here. Okay, and then once you've done that, because this bubble here is a function of x, you've got to times it by the derivative of the bubble itself. So that will be 6x. Okay, so that would be 6x. So this then gets multiplied to the top here. Okay, and then it will give you this. Don't forget, 3x squared times 3x squared. That will give you 9x to the power of 4. So now get a graph plotter and plot your graph, and it should look something like this. So your graph, your original graph, this here was a question here. We had to find the derivative, and then the derivative was this. So get a graph plotter and plot this. Okay, so you might have to punch arc tan into your calculator. Some calculators will not recognize this. So, but they're essentially the same. Okay. Well, anyway, get a graph plotter and plot this. Get a graph plotter and plot this here, and then it should give you this. And have a quick glance at it. Looking at the red line here, you can see that the gradient at looking at the red line, the gradient of the red line is 0 here. Now look at the blue line. Right at this point, it is 0. So it kind of makes sense. And if you look somewhere over here, you see the gradient here is quite shallow, and it's a negative gradient. It's going downhill. So here, if you look at this here, it kind of makes sense. It's going downhill. Well, it's a negative gradient and it's quite small. And then if you look at somewhere here, it's quite steep. It's quite steep here, and it's negatively steep. So again, it's negative. So the gradient here makes sense. If you look at this point here, it should be quite steep here. The gradient here is quite steep. Looking at the blue line here, it is quite steep here, and it's positive as well because it's going uphill. Here it's going downhill, and then if you look somewhere over here, the gradient is quite shallow, but it is going uphill. So looking at the blue line here, looking at the blue line, the gradient is quite small and it's positive. So by you plotting this and by plotting this here, you can have a quick glance at your answer, and here it does make sense. So you have a hunch that it's true, it's correct. Okay.